Alright, here's where things get a little bit tricky. The idea is that you want to rest the two wires on the top right next to each other, and then what I want to do is, because this is a regular thread, I start in this groove here, and this groove that I've got the left wire in, and I follow it down with the end. As I come down to the bottom, if I make sure it stays in that groove, I should now be exactly where it should be on the bottom. Now, while keeping this all together and from moving, I now want to get my mic on here. So I'll open the mic up a little bit further, and hopefully, I'm holding the bottom with my fingers, so concentrate on getting the mic on the two top wires, because I can always hold the bottom one. No, not open enough.
A really uncomfortable position here.
I got to get a light, check that from the bottom. Okay, I just checked, and it looks like I'm on, I've got the anvil of the micrometer right where I want it. So this should be a good position to measure, right there. Now this micrometer doesn't lock. Ideally I'd want a locking one. So now I'm going to pull this away carefully. Get the wires off of there. Take my reading. Okay, so I've got my my measurement, over wire measurement is right here, 1.994 inches. And I did take a small micrometer and double check my wire thickness, and it is 70 thousandths. So now I can plug these into my formula, and what I'm going to do is I'm going to assume that this is a 2-inch nominal, okay? And then I'm going to plug that all into the formula, and if it passes, then I'll know that this is a 2-inch nominal at this point, and it's got a taper to it. So I think that means that I can get a 2-inch backing plate with 8 threads per inch, and it would thread onto here. Now I'm going to jump ahead for a second, just to let you know I already assumed that that's what it was, because based on trying to track down what other people's experiences were as far as the size of their spindles, a couple of people had mentioned that they believe that theirs is 2-inch. Well, lo and behold, that's obviously not a standard that was adhered to very much, because I've done quick searches on eBay, and I can't find one backing plate or one face plate that has 2-inch 8 TPI. So that's kind of disconcerting, because that means that I think I'm going to have trouble finding a faceplate for this. I know that I've got my 4-jaw chuck. I would have liked to have gotten a 3-jaw at some point, but you know, even if I got a 3-jaw and tried to put another backing plate on it, I need a backing plate that's going to thread up to here. So, oh well. But let's run the numbers. So first, let me show you the formula we're using. This is the formula I got off of that YouTube video, actually. M is going to be the measurement we just took, is supposed to be equal to D, which should be the nominal dimension, plus 3G, which is the wire diameter, minus 1.5155 divided by N, which is the threads per inch. Now I made one adjustment to the formula that he had written down there, because in my mind, thinking from my days of algebra, the danger is with the way this is written is there's a temptation to add d to 3g, then subtract this, and then divide the whole thing by n. And I don't remember my algebraic rules about which operations go first. That might be what determines that. But just to make things clearer from my mind, I put the 1.5155 divided by n calculation in parentheses, so I know I will do that as a separate operation and before I subtract it from this other stuff. So now let's start plugging in some stuff. All right, now, so what I've got here is, here's my overwire dimension that I actually measured. This 2 is 2 inches for the nominal dimension that I think it is. We're going to add to that 3 times the wire diameter that I use, which is 70 thousandths, 0.070. And then we're going to subtract from that 1.5155 divided by 8. And again, I want to put that in parentheses just to make sure I did that operation correctly. Now, I don't expect this to be exactly this because there's clearance. In other words, there should be a certain amount of thread clearance between what screws onto the thread, and that's determined by, I think there are tables in the machinist handbook, which I'm going to have to obviously get one of those at some point, that determine what the allowable amounts of clearance would be for a given situation, I guess. So let me just crunch this real quick. Alright, so I like doing this in stages. It just kind of helps me keep things straight. So I've got, I took the 3 times 0.070, that's 3G, 3 times the wire size, I came up with 0.21. So I'm still adding my 2-inch nominal to 0.21, and then we're going to subtract from that the 1.5155 divided by n, which is 8 in this case, gives us this constant, 0.1894375. So that comes down to 2.21 minus this big whole long thing here, which I'll do that. And I get this number here, which is 2.0205625. 2 thousandths over 2 inches. So that is how much more than the 1.994 that I came up with over wire? Let's see how much that is. Oh, well, duh, that's 8 thousandths. Okay? So the only thing I can figure is that 8 thousandths, what they're accounting for, what we have to account for there is a couple of things. I think we have to account for A, again, we've got that thread clearance I talked about. 8 thousandths seems excessive, but I think also the thing we have to account for is I took my measurement here at the very end, and this is a tapered thread. So if I had taken the measurement back here, I'd probably be right in where I want to be with that number. So I guess, I still got my wires. Why don't I do that? Oh, wait a minute here. That doesn't make sense because 2.0205. All right. Pretty disgusted with my whole process here, so I'm going to try one more thing and then I'm going to hang it up. What I'm going to do is, because this is tapered, I'm going to take actual measurements here, here, and about here in the middle. And then I'm going to take over wire measurements at those same 3 points. And I'm going to run the calculations on all 3 of those locations and see what kind of numbers I come up with, to see if anything that I come up with comes up with something that sounds like, you know, a typical thread spindle size. If none of that works, then I'm going to still lean towards that this is a 2-inch tapered Hendey thread, which means I'm probably going to have to wait a while for something Hendey to come along, or I'm going to have to talk to somebody about you know, what they could suggest for solutions as to, you know, whether or not, you know, I don't know whether or not I could turn an adapter that would go on here and then allow me to put something else on there. I don't know. But rather than bore the heck out of everybody by having you sit here and watch me do all of these measurements, I'm just going to do them all and then write them down and come right back to you. Alright, here's what I came up with. I made myself a little diagram and I exaggerated the taper to show this is the skinny end of the spindle, and marked it A, B, and C. So at A, I took not nominal, I took the outside diameter measurements and got 1.972 at the widest part, 1.967 in the middle, and 1.955 on the skinniest part. And then I took the over wire measurements at the same positions, roughly the same positions. Now I'm going to run all those through the formulas and see what I come up with.